today I'm going to talk about how to unroute your network, or more specifically, I'm going to talk about BGP injection, route injection. So yeah, hopefully you guys all enjoy it. Woo. So here's a little bit of an outline. So I'm just going to start off with an intro to BGP, just so like everyone's on the same page when I start doing some of the demos. This is the first time I'm going to do live demos in a presentation, so bear with me. I'm super nervous. I'll probably be shaking and making typos the whole time. But I'm going to demo blackholing and spoofing for a bit of fun. And then I'll go just quickly over some mitigations of how to stop route injection in BGP. So why am I going to talk about this? Besides it's heaps of fun to do. So back in 2008, if anyone remembers, Pakistan knocked YouTube offline. So I think this was an accidental route injection which blackholed YouTube. Then we had a bit later in 2010, China swallowed 15% of the internet traffic. Specifically, I think they swallowed NASA and sort of more important things like that. And we thought maybe this had been fixed, but lucky for me, just December passed, we had Russia do something similar, routing Google, Facebook, and Microsoft through Russia. So it's actually still relevant. It's something that's really hard to mitigate against, but it's good to talk about it again. So who am I? Silvio, my co-organizer of B-Side, said this was too busy, this slide, and I'm like, well, it represents life, hey? So, in Canberra, I'm a tech lead of a security engineering team. I'm also a part-time lecturer at UNSW Canberra, teaching network security operations and a few other courses. Unpaid role, so volunteer in my spare time. With Silvio, as I mentioned, we do B-Sides Canberra in Canberra, obviously. Which is in April, so come along to that if you guys have time. With Silvio as well, we run InfoSect, which is a hackerspace in Canberra that does free events. I'm also the CFO of Hackers Helping Hackers. So I think we have about 15 people here today from Hackers Helping Hackers. Really, I just watch the books. I don't actually do that much for Hackers Helping Hackers, but they're out at the table outside, so go talk to them. They're doing a really good job helping people get into computer security. So I have an engineering bachelor's with specialising in DSP and digital systems. I have a master's in computer networking, done too many Cisco certs, some security certs, but you know. So specifically, I had to put my route exam and my BGP exam, even though I did it like, how long ago? 2010, 8 years ago, so maybe I'm out of date. So what is BGP? It's a standards-based protocol. It's used for the internet backbone. So I've given this talk to my class at uni to practice, and they said, you didn't tell us more what BGP is. So pretty much BGP is what runs the internet. So all the ISPs are running BGP, they share their routes, and this is how things travel across the internet. More features of it, it's a classless protocol, so it supports variable length subnet masking and summarization. It's highly scalable, as you would expect, hundreds of thousands of routes. Currently, the BGP table, and this is like from about a week ago, is 700,000 IPv4 routes and 50,000 IPv6 routes. So it's highly stable, as you would expect. It does routing while making decisions. It routes by enforcing routing policy. So as opposed to IGP, which is an interior gateway protocol, BGP will use route attributes to decide where to route the traffic. It doesn't use its own transport like other routing protocols do. It actually uses unicast TCP at port 179. So it's just a TCP connection to share routes between routers. BGP peers are not discovered, they're manually configured. So there's that peering relationship set up. They don't have to be directly connected, it's logical peering. So as long as you have a connection via TCP between the two routers, you can share routes, which implies BGP will need an IGP or something else underneath to know the routes between each other. So there are two types of BGP neighbours. There are external and internal neighbours. BGP has control plane security and it's extensible. So at the heart of BGP is the autonomous system number. So originally this was a 2-byte field, which is value 0 to 65535. And there's actually some private ASNs in there as well, which is defined by RFC 6996. But then RFC 4893 defined a 4-byte ASN because, like with all good things on the internet, we started running out. It started off with this AS dot notation, but these days it pretty much is just a 4-byte ASN. So for backward compatibility, they just popped a 0 in front of the older ASNs. So as I said before, there's two peering types. There's eBGP and iBGP. Today in my demos, I'm going to specifically look at eBGP because this is what is being used on the internet. So the difference is eBGP is peering between different ASs, so external ASs. By default, the TTL for eBGP is 1, so if you're at a longer distance than 1, you have to set that multi-hop parameter. And the way eBGP works is it uses the AS path attribute for loop prevention. So if you receive a route that has your own ASN in it, you don't keep that route. So iBGP I'll talk about briefly, although this will be the only point I talk about it because then we move on to eBGP. iBGP is when we peer within the same AS, so using it internal to our network. Again, many times not directly connected, and the way iBGP stops loop prevention is by suppressing routes. So an iBGP peer won't pass on routes it's learnt from another peer. So it needs this full mesh in the network, so you need to peer with every other router in your network. This can be fixed by using route reflectors and confederation, so splitting your AS into smaller ASs. This starts to get more complicated, and it's beyond what we're going to talk about today. So a little bit of looking at the BGP messages. So there's 4 main messages that BGP uses to start a session and start exchanging routes. So there's the open message, which is pretty much just setting up that peering relationship. The keep alive message, which it regularly sends to make sure its peer is still there. There's the update message, which will advertise or withdraw a prefix from its peer. And then the notification message is used to convey an error has happened and will close that peering session. And so a little bit of look at the attributes, although we're going to mainly focus on one today. The weight attribute is Cisco proprietary and locally significant, so it's only significant local to that router. We probably won't look too much at that today. Local preference is discretionary and more used for iBGP, and I won't touch on that today. And MED is optional and non-transitive. Transitive meaning it's not passed on through the peers. But what we'll look at today is the well-known mandatory ones. So these ones will always be in your update messages. And more specifically, AS path is the one that will be most effective in affecting our routes. So pretty much the routers will go top to bottom down these attributes until it finds the best route, and then it will put it in the routing table. So yeah, so as I said, the best path selection will go down those attributes until the router elects the best route for each prefix. So only the best route will be sent to the routing table from the BGP table, and only that route will be advertised to other peers. And as I said, the algorithm runs from top to bottom, so AS path will be the one we're looking at most. So here's the scenario. So this is what I'll be doing for the live demo. So what I've done is I've used Cisco's Viral, which is like the consumer CRL, if anyone's familiar with Cisco tools. And this just runs multiple VMs in an open stack configuration using iOS images. So they're all VMs. I upgraded my laptop to be able to do this demo, but I wanted to anyway. So what I've done here is that each router has been placed into its own AS. I've just used the first 6 ASs because it's just a demo, and I've just put the IPs relevant to the ASs. So AS1 has 111, AS2 has 222, AS3 has 333. Then I've got 4, 5, and 6. And AS1, 2, and 3 are fully meshed, which is why I put that switch in there. So AS1 is peering with both 2 and 3, 3 is 2 and 1, and 2 is 1 and 3, whereas the other ones are just peering with their adjacent routers. So the first demo I'm going to do is blackholing traffic. So I'm going to look at traffic going from AS2 to AS3, which should be a direct hop because they're fully meshed. And I'm going to black hole it through to AS1. So AS1 is the bad guy being red. And then I'm going to do AS2 to AS5, and likewise I'm going to black hole that traffic down to AS1 as well. And that's just to show, if you have a longer distance in your AS path, what that effect will be. So praying to the demo gods here that this will work. I've got it recorded just in case. So here's the network running. It's all active and reachable. Hopefully it stays that way. So what I'll do first is I'll hop onto router 2, which is this one up here. And I'll show you the BGP table. So I did this just before the talk. So that's the BGP table for the network that's going to be used in the demo. And as I said, I'll look first at going to AS3. So that's this subnet here. So the first thing we look at here is the AS path, which is this variable at the end. And you can see here, this is the shortest one. Obviously it goes direct, 3 to 1. And the other thing to note from the BGP table is if you have this arrow, it means this is what's been put into the routing table. You can look more specifically if you do show IP BGP and then put your route in. And you can see there which one has been put in. So 2 paths of available, and this one has this AS path, and this one has this AS path. So I'll just do a quick trace route to check. Let's hope it's up. Yep, and you can see even in the trace route that it's gone straight to AS3. So what I'm going to do before I start my attack here is I'm going to, has this cool option of doing packet capture. So I'm going to do a packet capture between 2 of the nodes. Oops, not that one. Always do that. So create a new packet capture. That way I can show you the packets that I'm sending to do the attack. So Viral has this tool called Routem, and Cisco have created this specifically so that engineers can test their networks by injecting extra routes. I'm not sure if they realize that we could also test doing bad stuff, but that's what I'm doing. So if I open Routem here, I've prepared some demos. So if I cat demo 1.1, which is the first demo, and I'll actually launch the demo because it takes a little while for the routes to change. So in the file here, it pretty much just sets up a BGP relationship with router 3, and it's actually just sharing this route here that I want to inject into that BGP network. If I go back to the packet capture I just started and open it, not delete it, which would be something I'd do. Okay, so it's opening in Wireshark. Is it big enough? I can make it a bit bigger. Yep. So if I just filter on BGP, you can see here some of the messages that BGP is sending. We have the open message that I talked about. So this is my Routem creating that relationship, some keep alive messages, and some updates. So the update is the one that is the one we're interested in. If I dig into that a little bit deeper, you can see all I'm doing is saying, hey, I know about this route here. If you have this route, send to me. So if I go back to router 2 now and have a look at my BGP table. So you can see here, the BGP table for that subnet has changed. But even though this has dropped down to it being like 1 hop away, AS1, you can see that it actually hasn't changed what's in the routing table. And I can test this by doing the trace route. So you can see it's still just going straight to 3. So what happens if you're advertising the same prefix, it's just going to stick with what it already knows, and that's part of just maintaining that stability. So I go back, let me go back, and I'll show you demo 2, or demo 1 part 2. And here I'll launch it again, so it takes a little while. This time I'm going to advertise a more specific route, which is 3332/32. So this one's more specific, so it's a different route. And if I head back to my BGP table, you can see this has gone, I've stopped that attack, so that's gone back to being the full length that it was. It should come up soon. There we go. So there's the new route it's learnt, and the shortest AS path is 1, so that's been popped into the routing table. Now if I do my trace route, it should work. Yep, so it's dropped into AS1, so it's not getting to where it should be going, and we're blackholing that traffic, which is good, but it was a bit annoying because we had to do a more specific route. So we'll look more at this way, 2 to 5, where we've got a bigger option of routes. So if I do show IP BGP again, you'll get sick of that command. We see 5550, and as I said before, there's different ways to get there. So if I go back to my diagram, it can go from 2, it can go 1, 3, 6, 5. It can go 2, 3, 6, 5, or it can go 2, 4, 5. You know, there's multiple ways. Oops. Come back. There we go. So the shortest way is 4, 5, directly that way. So if I do a trace route 5552, you can see it goes through AS4 and then it goes through AS5. So if I attack this one, which is demo 2, and this time I'm just doing a /24 again, or what's already in the routing table. But because of the distances, when I look at this one, that takes a little while. One more time. Just one more time. Oh, maybe one more. There we go. So you can see now that the AS path has significantly changed. So we're looking again at this 555 subnet, and the shortest path now is directly to 1, which is our attacker, and that's been put into the routing table. So now when I trace route to 5552, it's dropping, should be going straight to AS1. So I'm blackholing that traffic as well. So you can see if you're the attacker and you're attacking something further away, you can really affect your nearby ASs a lot more readily. So, yep, so that's the first demo done, and it didn't fail, so I'm pretty happy with that. Thanks. Yeah, so it works. So equal hops with more specific route will blackhole the traffic. Equal hops with the same subnet, the route won't change, and that was a bit annoying. And I've put a little star here to note that I mentioned before that BGP is run over TCP 179. So an attack that people are aware of is that you can brute force that source port, because you know the destination port, and pull and send down those notifications and tear down the sessions, and then your route will be the newest one, the oldest one learnt, and will go into the routing table. So less hops with the same subnet will blackhole traffic. Yeah, so as I said just a second ago, having to go more specific is annoying. Don't people just, like, who's going to accept a /32 route in their BGP table? And like I said, BGP Session Teardowns is an attack vector for that. So authentication between peers will stop that BGP Session pull down. So I wanted to do a more interesting demo now that we've verified that it works. So this is my spoofing demo. So we're starting off with our Crikeycon vulnerability researcher. He's come to the conference. He thinks he's pretty good. He's found his or I should say she's found her 0 days in some awesome software and she wants to report it. So she's going to go to CERT Australia and report her vulnerabilities. So the traffic from CERT Australia, I'm going to try to pull into AS1 and spoof it. So this is a more tricky demo, so hopefully it works. So we've got servers and everything. Oh. So yeah, so I've got nothing in my directory. This is my Crikeycon guy, so girl guy. He's going to go to, he doesn't like GUIs because, there's too many vulnerabilities in GNOME and stuff, so he does everything command line. So he's going to go to the website. Also, there's no GUIs in Firewall, so he goes to the website, gets his web page. Okay, so this is the CERT web page. They really need to work on their web development, but it's pretty simple. Just says, welcome to CERT Australia, IR and responsible disclosure. For assistance in disclosing vulnerability, please email certau.gov.au. certau@gov.au. Anyway, so this attacker guy knows this is happening. So he's injecting the route. We'll go back to this route. And we head back to here. I'm just going to remove that file. And now the new vulnerabilities needs to be disclosed, so they head back to CERT. Should just go up. Yeah, woo, okay. Hopefully it's the right one. Let's see. So, look, CERT's changed their disclosure policy. So for assistance in disclosing a vulnerability, CERT-AU is now using B-Sides Canberra to deal with all vulnerabilities. Yeah. Please email info@bsidesau.com.au with all your sweet 0 days. So that's it. That's the last demo, but that was a bit of fun. Yeah. Okay, so last part of the talk will be on mitigations. Pretty much just route filtering, but 700,000 routes on the internet. Who's gonna filter all those ones? And this is the problem, I think, that makes BGP route injection just keep popping up constantly. So I spoke to my friend at Cisco, and he's like, I'll give you a BGP routing table. So I have to say a thanks to Nath Lanaves from Cisco. So here's a copy of the current BGP routing table out on the internet. And there's our 700,000 network entries there. So what is best practice and commonly used is using an internet routing registry. And using an internet routing registry will allow you to correlate the AS number to what IP address should be coming from that AS number. So it can be used, it's pretty much a free service, and it will allow you to correlate, to validate the contents of a BGP announcement message. So this is their FAQ, and you can read about it. But what is really neat is being able to do it programmatically. So using RT-config, you can pull down and automatically configure this. Also do filtering, weighted base filtering. So if you filter out all your networks, or filter out networks coming from other ASs, you're going to lose that redundancy in BGP, which we really need. So weighted filtering will allow you to say, if Google's advertising this, I trust it more than if this guy's advertising it. But if Google goes down, I'm happy to go this way. And that's the end. So thank you to Crikeycon. And any questions? We all get to go to the bar. Yeah, awesome.
I have a question.
Yeah.
So would adding a blockchain help?
Actually, someone told me yesterday, I don't know how true this is, but that blockchain can be used to validate BGP routes by distributing that. I don't know. He said there's been research on it. I'll have to go back and check.